Thank you for joining The Ones Changing the World, India's first Future Tech Meets Sustainability podcast. And today I have with me Mr. Krishna Murthy Jattavallabhula, who is a postdoctoral associate at MIT CSAIL with Josh Tenenbaum and Antonio Torralba. He earned his PhD at Mila and the Robotics and Embodied AI lab. He's advised by Liam Paull over there. Krishna's research vision is to enable embodied agents to perceive reason and act intelligently. To achieve this, his work intertwines our understanding of the world with deep learning machineries. Krishna's work has been recognized with PhD fellowship awards from NVIDIA and Google and a Best Paper Award from IEEE RAL. So Krishna, I really appreciate you taking time and being part of the podcast. Why don't we start with a brief introduction? Because when I kind of chanced upon your work, I mean, your work is extremely diverse. You're working on building intelligent machines. You had your hands wet with NVIDIA and Google, autonomous vehicles. So I would love it if you could give your introduction and your journey.
Thanks for having me here. And I guess the best way to the way I look at myself is I'm primarily a roboticist by training. So most of the work that I've done, it spanned several domains, as you pointed out, but most of them still come back to robotics and like how robots or intelligent agents can eventually be deployed pretty much everywhere in our daily lives. So this all started back as an undergrad when I was just primarily interested in building robots as a hobby. And I used to do robot contests at that time, like building robots, participating in like technical competitions all over the country. And I guess slowly I realized that I'm more interested in carrying out research in this field. So I decided to like pursue a master's to first kind of, get to know my interests better, because robotics as a field is really, really broad. There's all sorts of, there's predominantly industrial robots. There's robots that are outdoors. In many countries these days, there are autonomous cars, or at least autonomous cars with human operators. And there's also robotics for households. So just to explore the breadth of applications, I decided to do a master's first. And during my master's, I worked a lot on robot perception, or like how do robots perceive the world from cameras primarily. And this to me was really challenging because perception is a really hard problem. Like humans just look at their surroundings and immediately make sense of what's around them. But this is a really hard problem for robots because all they see is like numbers streaming in from cameras, and can you make sense of the world from those numbers? And yeah, so gradually that's when I got into robot perception. And then I figured I needed to do a PhD to get deeper into research. And during my PhD, I did a variety of work, again, primarily in robot perception, but I also got into robot planning and control. And I think there was also a significant shift from outdoor, like autonomous driving, to more of the indoor robots kind of work. And yeah, now after my PhD, I'm here at MIT. I've just been here for 3 months, so it's still early days as a postdoc, but yeah, that's my journey, a very brief snippet.
Where does the current innovation stand with robotics? If we had to get to autonomous robots, which has the same dexterity as us, because the way we learn, because you mentioned, we've got multimodal learning, a perception, how we perceive the world, and to kind of represent that in a machine, it's an extremely different problem with an embodied AI, a robot. How does that work? Where does the current state of the art research stand when it comes to robotics?
There has been significant amount of work in robotics. So over the past several decades, maybe the last 30-40 years have seen the most improvement. And I guess there are these days, there are like several systems that are deployed in industry that actually are much more efficient than humans at a few kinds of tasks. For example, a lot of logistics companies are using warehouse automation technologies where robots just ship products. Like they help in making this pipeline autonomous to a large extent. And we also see like several manufacturing chains make heavy use of robots. And the key thing here is if you look at an industrial setting, it is you have a lot of things under your control. So you can control the environment, you can design the environment to suit your robot. But the challenge really lies when you want to bring robots out of controlled environments into the real world. So think about autonomous cars. So autonomous cars have, there's been, we could sort of call this a great promise, because for this last several years, autonomous cars have been promised, but each year, the actual deployment estimate date just keeps getting pushed back a bit, because the more roboticists work on deploying robots into the wild, the more challenges they encounter. So I guess one of the main challenges for robots is to be present among humans and navigate amongst humans and interact with them, because that is just not the scenario that robots have excelled at. They're excellent at environments that you can control, like warehouses, where you can control everything. You can set up cameras to kind of estimate the state of each robot, and you can basically, if a robot is going haywire, you can just tell it, you're not where you think you are. You need to correct yourself. But it's unimaginable to do that at scale. Like even autonomous cars, if you look at it, some of the most successful solutions that exist currently, they work in cities or like in very well constrained highways, or even if they work everywhere, they have some restrictions on the kind of weather conditions you can use it in and all of those things. So like getting a solution that can step out of these controlled environments and basically work everywhere in unconstrained environments is the biggest challenge for robots. And as you rightly touched upon, a big chunk of this boils down to good solutions for robot perception. And basically, I think of perception, the best way to think of perception is like this. Imagine you just wake up in some place that you don't know and you need to get home. And what you do is you'll kind of look around yourself. You try to localize, as they call it, like you want to know where you are. And then you also need to know what you need to do to get to where you want to go. So if I wake up today and I need to go to my office at MIT, I'll make various kinds of plans. So do I just take the subway, or do I take a bus, or do I just feel like biking or walking because today the weather is so pleasant? So there's a lot of things that we humans just subconsciously take lots of decisions on. But for robots, they need all of this process needs to be made explicit. They need to know where they are. They need to know what the goal is, and they need to know what options are available to them to achieve that goal. And if any of these go wrong, the consequences can be disastrous. So yeah, that's basically one of the biggest challenges with robotics right now.
Right, you're pointing out to the SLAM problems with the robotics, and then you also mentioned about autonomous vehicles, and you have spent a considerable amount of time with autonomous vehicle, and you mentioned that obviously that some of the top minds around the world, be it in the academic area or the startups area, are working on the goal of creating that level 5 autonomous vehicle. What, according to you, are still maybe those challenges? If we kind of overcome, we'll be able to come to an autonomous level 5 driving solution.
Yeah, this is interesting, and this is a problem that we talk about often. Like I've chatted a lot with my academic advisors and collaborators a lot, especially early on in my PhD when I was kind of sure that I wanted to do autonomous driving. But then I got more interested in some of the more fundamental problems in perception, like without coupling it to any particular task like driving or robots. I think I'm now more interested in just understanding perception, reasoning, and solving those as standalone so that these can be deployed among a wide diversity of solutions. But when it comes to autonomous driving alone, so we did some work a few years ago, and it was called MapLight. It was a system for autonomous cars to navigate without a prior map and without a prior dense geometric map, I must say. So why did we do that? And that really is one key answer to this question. So if you think about most autonomous driving solutions that are deployed today, they're deployed in urban centers where roads are really well maintained, paved, and even there they have like geographic restrictions on where the car can drive itself and where you need to take over. For example, construction sites just create new road rules that systems currently are not equipped to handle. So they need some form of human intervention to be able to handle that. So, but if you think about urban centers, they account for, just speaking about the US alone, maybe 20% of the roads in the entire US are urban centers. And we had some initial numbers from a report early on in our paper. I need to look up the exact number, but it's around 80% of the roads, they're rural and they're not well paved all the time. They're not too well maintained. And even to map like a little chunk of a city block, it takes terabytes and terabytes of data. And these maps go out of date pretty quickly. So if there's construction or the road gets repaved, you need to rebuild the map for the cars to be able to localize themselves and drive around better. But think about rural roads where there's like vegetation around the road, which is pretty seasonal. It grows and then sheds, or maybe there's snow, there's rain. So it's impossible to keep an updated map of the entire US alone. Like you can imagine how big a problem this is going to be if you want to scale it around the world. So one challenge to tackle is how can autonomous cars drive around without maps? And the way we did this was think about how humans do it. Like humans don't have a very dense map of the entire world when they're driving. And in the extreme case, or maybe in most cases, humans do not really know where their destination is. They rely on some external navigation mechanism, which just tells them, go take the next right, and then cross 3 intersections, and then take a left, and then just keep going straight until you reach your destination. So those are broad kind of topological instructions that humans are able to follow. And like within each instruction set, like, take the next right, humans are just responding to what happens in the environment. There's a purely reactive behavior. So we try to do this in an autonomous car. We just say, now we have an autonomous car, which does not have a dense map of the environment. It just has weak topological cues. Sort of the Google map analogy saying, you need to take a right in the next intersection and then cross 3 intersections and take a left. So that kind of a loose instruction. And in between all of that, you need to drive reactively. So we develop like elaborate localization algorithms when you had like these very, very weak topological maps, and then can you reconcile them with your local sensing data to determine whether or not you've reached the intersection and carry out planning and control and all of that. So I think that's a really interesting direction for me that autonomous vehicles could take, like a mix of, or like currently autonomous vehicles have this crutch of having this known very dense map of the world to be able to drive better. So they're like training wheels of some sort, and those wheels need to come off at some point for them to be able to navigate in the world.
Right. Yeah. I mean, this seems like such an easy problem, but it's such a huge challenge because when we humans, when we drive, there's a lot of intuitiveness. I mean, if we take a left, right, how do we build that and represent that into machines? Possibly. I mean, if you today, I think there is some fantastic innovations happening, in the space of AI, deep learning, and there's some great models out there, with GPT-3 or Gato, which and OPT 175. That's awesome innovations happening, but most of them are in a very narrow space and can do one specific thing. Right now, I think whatever we're building, the race is to get to possibly a general purpose machine, a machine that would be able to possibly do not just one thing, but possibly a couple of things, or maybe emulate us humans. Your work, research work, is I mean, when I read that you've been spending time in building intelligent systems, would you like to talk a little bit about building intelligent systems? And if you're building intelligent systems, what are the things around that you need to integrate to build an intelligent system?
Yeah, this is, I guess, my favorite question so far, and I talk about this often, so people who already chatted with me might know some of my stances and on all of this. But it's good to be able to share this on a platform like this. And so we've witnessed lots of advances in AI and machine learning over the past few years, especially from 2012. There's been a significant shift in the community. Like the computer vision community is now shifted completely to using deep learning techniques for perception. And as you said, more recently, we've been seeing all of these large language models taking over. So AI has significantly, penetrated into all of these fields. And people are just beginning to use AI technologies and training them from scratch, essentially on large chunks of data. So one pattern I've noticed with all of these successes is there's a large amount of compute involved, but there's also enormous amounts of data involved. So we need data of the scale of ImageNet and large GPUs to make connects possible for most tasks that are used today. And for language, we needed all of these billion parameter language models that are coming out. So they need lots and lots of data to be able to succeed. And I kind of buy into the fact that with lots of data and lots of compute, these models will keep getting better. But unfortunately, real world robotics is one area I feel you will not get that scale of data for. And the reason is quite simple. Like, imagine one robot running around your house, and in a few days, it'll be able to collect data of your house alone. And your house configurations might change over months and years. And the data just does not simply account for all possible scenarios that might occur in your house. And think of all of the other houses you might have in the world. And if you think about just ground robots versus flying robots versus quadruped robots that just walk around, there are different kinds of robot mechanisms, robot structures, and different kinds of sensors for each of those robots. So getting data across all of these sensory motor configurations at scale that is required to train all of these models, I think it is like extremely hard to imagine a scenario where this would happen, especially with all the concerns around collecting data amongst humans and all the privacy and other issues that might arise. I don't see this happening anytime soon. So what's our best bet in that case? So assuming you'll get a large quantity of data, but not enough to just be able to deploy all of these billion parameter solutions, what's the best way ahead? And my answer to that is humans have a very good understanding of how the world works. And even if you look at all of the robotic solutions that existed over the past 20 years, they've all had this pattern where you take your best model of how the world works and you implement that in a robot, and that's how robots start reasoning about the world. So think of all of the rovers that you send to all of these planetary missions. rovers have been sent to Mars that have survived for more than a decade on like another planet where you cannot control a lot of things. And that's all because you have good mental models of the world programmed into the robots. And that's where I want to take my research to. Like we know a lot. Like we've invested a lot of several years of research in computer vision, computer graphics, and like physics to understand all of these. And my research goals are: can we somehow bring all of these mechanisms that we develop to understand the world, and can we like embed these within these deep learning systems, as opposed to like throwing all of the data away? So a significant shift when deep learning took off was people tend to forget or like discard all of the knowledge that they have a priori, like classical robotics, classical computer vision, that all just somehow got sidetracked. And all people want to do, or most people these days, just want like train models, throw enough data, throw enough compute, and hope that it works. So my research program or agenda is to kind of bring back all of the things that we know about the world and integrate them with deep networks, as opposed to throwing them away.
Lovely. Yeah. I mean, obviously you mentioned, there's one field of researchers who are working on creating or trying to build intelligent machines with, overloading and feeding the data. And you mentioned that obviously, that with the data privacy, there might be shortage of data, but from my side, I see the other way around, because we getting into a connected world, and I think in the next few years, because of the us transitioning from Web 2.0 to Web 3.0 and getting into a digitized world, the metaverse, I think there'll be humongous amount of data collection from anything and everywhere, right from your augmented reality, virtual reality glasses, wherever you kind of look, all the data will be connected to the cameras on these autonomous vehicles. I mean, the kind of data that's going to be collected to these sensorization of the entire world through IoT, Internet of Things, there'll be humongous amount of data, I think, being collected. And yes, I think privacy is obviously currently we've been ignoring, because we are in a race to acquire data, because data is the oil, and through data we can create intelligent machines. So we are in a catch-22 situation. So I feel obviously there's going to be a lot of data which is going to be collected, but yes, your approach of building these world models and not going towards too much of data, but taking all those world models and building something, I think it could be a great approach. Now there is when you're kind of building AI from your lab to research to going into industries, real world use cases, there's always a gap. It takes a lot of time. Where do you think is the problem, and what can be done to create kind of a like an academia, government, and industry stakeholders all together? Because even with, I think, innovations, what's happening today is that everything is siloed. Can that approach, maybe like an open approach, lead to faster acceleration of these technologies?
There's been this big revolution of industry-led open source projects. For example, a lot of the deep learning libraries we use today, maybe just take names: PyTorch, TensorFlow, JAX, and all of these tools are now developed and maintained by industry. And this also, but they're maintained in an open source model. So anyone, not just at academic institutes, but anyone out there can contribute, like fix bugs and so on. So this just makes progress much faster. And we're already seeing how these libraries are being used by everyone to build all of these exciting new tools. So yeah, I kind of like the trajectory. We're not like, obviously we're not quite there yet in terms of where we want to be, but the trajectory looks quite promising.
Yeah. I think we living an exciting point of time, with so many cool things happening, and geography becoming history. Just last week, I was having a conversation with the ex IIT Delhi director, Professor Rao, and he was mentioning that how it's becoming more and more difficult to gather or hold students in the classroom, because I think the entire education industry is upending, because students are understanding that the internet is the teacher. The MOOCs, the massive open online courses, these Coursera's giving you these courses, education itself is transforming. And I guess these democratization of knowledge by these open AIs I think it's really really cool, because it gives access for anyone, like even the Facebook OPT 175B. It's created access. Anybody can, as a researcher, you can go and access these tools. Would you like to talk about the cutting edge of innovation right now? Because I was reading about Gato's multimodal, multitask, multi-embodiment generalist policy agent. Then there is obviously the OpenAI's Dolly 2 plus versus Google's Imagen AI, which AI text to image generator. Like really really cool things happening. So would you like to talk about the state of art of innovation with AI, and what do you see coming in the next few years?
Yeah, so I mean, as you said, we're living in really exciting times, because all of these technologies are coming out, and they're coming out at a pace that it's almost hard to keep up with them. And when I started out as a master's student, there were probably, I know, like if I look at the computer vision and pattern recognition tab of archive, we probably used to have like 8 to 10 papers on average per day, and now it's almost an order of like 100 per day. So it's insane to see like the pace at which research has grown, and because of this, it's also hard to keep up. You could have imagined a time where you just go to a conference and there are like 50 papers at the conference, and you read all 50 of them, you're up to speed. But this is no longer the case. There's like 100 papers a day, and that's just like computer vision. So yeah, but there have been like a few major breakthroughs. So as you said, all of these large language models are extremely cool, and especially now people are beginning to explore these connections between language and vision. So Dolly 2 is it's pretty amazing. People have always thought that generalization is actually a very hard problem for all of these models, but they're showing that with scale, you can achieve some forms of generalization. There's not to say that all of these models are extremely general and can do anything. They have lots of limitations right now, but if you'd asked me 2 years ago, if you told me that in 2 years there'd be this amazing model where you can just type in text and it generates images, I would have not believed you. So it's kind of amazing to see all of this progress. Google's Imagen is also an example. But in terms of robotics, one really big innovation that we're seeing because of all of these models is these models can be used to specify goals. So if you thought about robotics in the traditional sense, this is how a traditional reinforcement learning pipeline for robots would look like. So you have a robot and you have like an environment, either real world or simulator, and then a robot carries out actions. And at the end, the robot gets some reward. And that reward specifies how close the robot got to the goal. And this reward had to be like manually specified. And to be able to specify this in code, you first need to convert that into math. So imagine a simple task where a robot needs to open a drawer. So you would need to somehow programmatically encode the fact that, if at the end of the episode, the robot has pulled the drawer just enough to an extent, then there'd be a threshold there, then it'd be considered open. And that's just a drawer opening task. But think about a task which now involves like make a cup of tea. So there's like lots and lots of steps involved in that. And how do you even score like whether the robot has successfully made this cup of tea or not? But one avenue where all of these models shine, the large language models, is you can use them to specify goals. So because language has such a rich connection, like it has this inherent notion of semantics, inherent hierarchy defined. You can use that to do lots of interesting things. So you if you just say fetch a cup of coffee, then you can use language models to kind of reason about what do I need to prepare coffee in the first place. So I need a cup, I need I know milk, I need whatever coffee, and all of those hierarchical plans just keep forming. Uh, we've been seeing some initial work in the space. I wouldn't say the space is like made a major breakthrough, but we've seen initial very promising steps. I can point to like the SECAN work from a couple of researchers from I think Google and every robotics. That's pretty cool. And there's also some work coming in right here from MIT. I work with Antonio's group, so they had a paper, I think, which came out a few months ago, which was trying to do something similar. Like, can you use all of these large language models to enable robots to plan? So robots, or like any intelligent system to plan, it needs like some abstraction of the world. You need to be able to specify all of this in like a very symbolic language, but natural language makes it just a little bit easier for robot-human interaction. So I guess that's one area I'm really excited to see progress in. That's not an area I actively work on, so that's all the more reason for me to I always get surprised when there's exciting results in that space. But yeah, I guess that's where the state of the art is at. But I should at this point not all be glorifying, and I should also say there's like a lot of risks associated with all of these models. Like there's a lot of bias in all of these large language models, as we've been seeing. So it's kind of important that as we begin to train all of these, we also think about ethical implications and like do these models amplify biases in the data set to an extent that these might create harmful impact in the future. So I think that's one really underappreciated area. Like people are excited about seeing research, but I'd also want to see more and more researchers thinking about these problems and coming up with solutions to or plausible solutions, and collaborating with the groups that design these large models. So yeah, I think there's that side to emphasize as well.
Right. Yeah. I mean, we sometimes the tech industry gets really excited by the things that they're building, because I think we laying the building blocks of what could be general purpose these intelligent machines, maybe possibly in the next possibly 50 years. Not giving timelines, but that's what I think. So, but yes, there should be an approach of creating these tools which have the are human first, because sometimes we can lose the sight with our excitement. Now there are a lot of these students here in India who would want to, because of the access of internet, are excited about the possibilities and want to build or be part of an institution. What would be your advice to them? Where do they start from?
I guess the main aspect for them to consider is what their primary interests are. I guess a lot of people that I talk to often, they kind of know that they come and tell me that they want to do a master's or a PhD. All of the extensive virtualization that has taken place, there's a lot of resources online, and a lot of people around the world have been making research more accessible. So if you look at conferences, for example, early on, and it's not much earlier either. Like if I just think 3 years ago, like 2019 maybe, the only way I could access to all of those conferences was I would have to register, and then I would have to read most of those papers. But now there are these accessible like 2-minute videos of all of these papers. And the other thing is people themselves are like advertising. So since people no longer read these 8-page or 10-page papers, they've gradually, resulted in newer forms of dissemination. So there are blog posts accompanying most papers. Or now, I guess the trend is to get a tweet thread of what your paper does. So like being on Twitter, following the right researchers has helped me a lot, because that has helped me just keep up with all of the interesting research that's going on. But that's not to say like people should be on Twitter. That's not the message I wanted to convey. But I want to say that there's a lot of resources out there online that people can use to understand all of these new research. Like even if they don't get all of the technical details, they'll get a good sense of what's happening. And I guess that's really important, because most of the times, a lot of people I see, when I ask them what really motivated you, they'd say, I saw this paper and then I got an idea that I could maybe do this, and that resulted in a research project of their own. So like that's pretty useful. And also, like whenever you get the chance to talk to other people in the area, like just feel free to reach out to them, like talk to them. If you're at a conference, like don't hesitate to strike conversation with all of the other people that you want to talk to. And all of those connections have helped me a lot, like in several ways. So I would encourage them to explore like what their true passions are. And once they have a good sense, or even if they don't have a good sense, they have a good sense of the distribution of where they want to be, like take steps to kind of get there. And it's usually a long process to get there, but if you're passionate enough and you're willing to work through, then definitely it's possible.
Lovely. Krishna, really appreciate you taking time and being part of the podcast. Like I mentioned, I think we're living in fantastic point of time. Just 3 years before, just before COVID, things were completely different. But this COVID, I think, has been such a game changer. Obviously, it's created huge disruption, but the benefits has been insane, because what would have taken possibly maybe a decade has happened in two years, because like I said earlier, we're getting into the web 3.0, the transitioning from Web 2 to 3.0, the metaverse, the IoT convergence with augmented reality, virtual reality, 5G, all of these technologies are in a nascent stage, and they are about to kind of explode. And it's so very important to kind of direct it towards the right direction. You mentioned about the problem with AI, obviously it's data hungry, and the power that it consumes, that's a huge problem. So there's so, and the biases, but we can, if we direct it at the right place, I think we'll be able to create something which is really, really fantastic. My last question to you: what's your goal? What's your vision? And what do you see yourself in the next 10 to 15 years building?
Yeah, so I was lucky to have identified this goal like very early on. So my goal is to have a long career in research and to be able to eventually direct a research program of my own, trying to build towards all of these intelligent systems, make the best use of both machine learning, but also to not throw away all of the classical theories in robotics, computer vision, and graphics that we've developed over the last 3 or 4 decades. And my main goal is to keep pursuing a research program, and I'd be really excited about directing a program on these directions sometime soon in the future.
Krishna, wish you the very best. Thank you for being part of the podcast. And to my listeners, if you like what you see in here, then please press the subscribe button. And until next time, see you guys. Bye-bye. Thank you, Krishna. Really appreciate this.
Thanks.